What up, folks? We are now into probably the most important lesson of the entire unit on polynomial equations, which is solving polynomial equations. So basically everything we've been doing in this entire unit has built up to this. We're finally going to use all that factoring stuff, and we're going to use it to solve polynomial equations. And so before we do that, we need to take a brief history lesson on solving equations. Remember what solving equations is all about. Okay, it's about undoing operations and isolating the variables. So whenever you see the word solve in the instructions, what that means is we're going to be undoing operations and we're going to be isolating variables. And the reason why is that we want to discover what are the possible values for the variable that make a true statement. Okay, so solving is we want to know what are the possible values of the variable to make a true statement. Okay, so that's a huge note. What are the possible values to make a true statement? All right, and we get into some simple stuff. So far with our history of solving equations, right? If we do just a brief example of solving equations, and so far all we've ever done is work with something to the first power. So if I had something like 3x minus 7 is equal to 11x plus 25, just making stuff up. What would happen? How do we solve that? That's only in the first power. So if we notice, x is simply in the first power, so that just means whatever we can do, we solve for x. And so we can, in this case, what I would do is probably subtract 11x from both sides. I'd end up with 7x minus 7 equals 25. And then I would add 7 on both sides, this 7 here, so I'd have 7x equals 32, and then divide both sides by 7. And so we would have, that. That's how we used to solve. I have the variable by itself, it's x to the first power. That's what we used to do, undo operations. Now what we're saying is the value for x that would make this original statement true is 32 over 7. And that's how that would work in the past. But now what happens when we have something x to the second power, we have to have a whole nother thing. X to the second power is a bit different. And we have to know how. So whenever we have anything that has x to the second power, which is everything we've been dealing with, polynomial equations we've been dealing with x to the second power, it's a bit different. We have to use a logic exercise in order to solve. So whenever we have something that's a larger exponent than the first power, we have to use what's called the zero product property. So the zero product property is the skill we're going to use. Now, the zero product property operates on logic. Okay, so the whole zero product property operates on logic, and so we have to use a logic exercise. So zero product property operates on logic. We're going to have to use logic to figure this out. And so how does the zero product property work? So if we're dealing with the zero product property, we do have to remember a thing. Okay, so it's a thing with math. It's not as straightforward as solving for original stuff that we used to solve. So we have to operate on logic. Let's say, let's just say that we're multiplying three things. A times B times C. And when we multiply them all together, we get 0. Okay, so let's say that's the case. That we're multiplying three things and we're going to get 0. If this is the case, we have three possibilities. And what we have to do is use logic to identify those three possibilities. Okay, so we have three possibilities. What are they? Either A is equal to 0, because if A was equal to 0, 0 times anything is 0, true, right? Yay, thumbs up. So either A is equal to 0, or B could be equal to 0. Okay, so either a could be equal to 0 or this b could be 0, because if this b was 0, then we get 0. So what would happen, if we had 0 times b times c equals 0? True. Or if b was equal to 0, a times 0 times c, that equals 0? True. And then there's one other possibility, okay? Or c is equal to 0. And so we have that possibility as well, because a times b times 0 equals 0. True. So with the zero product property, we now see something in logic. Okay, so if we have multiple things being multiplied and their product is 0, that means either thing is equal to 0. Now that's a handy-dandy tool. So for example, if I had a number, let's say it looked like this, and then I had another number, let's say it looked like this, I had another number, and let's say it looked like this, and that whole thing equaled 0. Okay, so let's say I had these three complicated things, and the whole thing is equal to 0. It means now I have three possibilities. Okay, so what I'm looking at is three possibilities because the zero product property. If it's equal to 0, I have three possibilities. In this case, a is equal to 0, or b is equal to 0, or c is equal to 0. Those are my three possibilities because that's a true statement. So in order for the zero product property to work, okay, in order for the zero product property to work, everything must equal 0. And so what we have to do for the zero product property is to make sure our equation equals 0. So make sure our equation equals 0. And we can do that through basic undoing principles, right? We can totally do that in any case. But once our equation is equal to 0, and this only is if we have x to the second power, x to the third power, something and higher, we can use now the zero product property. So this is a huge note. If you don't have this all down yet, hit pause now. Make sure you have all of this. This is a huge note, and that's the deal. Because with that note, we can now apply the logic. We can apply the logic to all these equations. Okay, so we're going to apply that logic of the zero product property for pretty much everything. So here's the list of equations that I'm going to present to you so that we can solve all of them. Now I have a pretty straightforward one in number 1. I have a not so straightforward one in number 2. I have a downright tricky looking one in number 3, and 4 and 5. Okay, so all of these require some interesting stuff, and then I'm going to finish with a word problem. Okay, so that's what we're going to do. We're going to model all of that. And if at any point in time anything becomes tricky, what you need to do is hit pause and rewind as necessary. Okay, so we're going to start one at a time. This is the big bulk of what is happening. So first questions first. We have some crazy looking stuff being multiplied, and the result of that multiplication is 0. Okay, so we have two things being multiplied, and their product is 0. So right now we're looking at something really straightforward. This is easier than it looks. Okay, so this whole thing is way easier than it looks because of what we just did with that note. Okay, you've got to remember that note. So this is easier than it looks because of the note. Okay, the note was a times b times c equals 0. So either a equals 0, b equals 0, or c equals 0. And look what's happening here. In this problem number 1, we've got two things being multiplied. Their result is 0. So what does this mean? That means now we have a logic exercise. This means that either 5x plus 1 could equal 0, right? If this whole thing was 0, then 0 times anything is 0. Or x minus 2 is equal to 0. Okay, so we have these two things that are happening because hopefully you recognize that they're being multiplied to one another. And if their product is 0, then the zero product property kicks in. And again, remember that note. Big note right there. Ta-da, big note. If you don't have it, copy it down. Okay, so we have these two possibilities. And so what we have to do is solve each possibility. Okay, so we have to solve each possibility. And then we come up with our solution set. So in the first equation, 5x plus 1 equals 0, we solve for x. So 5x could equal -1, or x could equal -1/5. All right, so we have made a solution for that. Now remember, we had another equation, or x minus 2 equals 0, or x minus 2 equals 0, so x equals 2. Okay, so we have two possibilities. X could be negative 1/5, x could be positive 2. Okay, so we have two possibilities, and we can easily check our answers. If we substitute back in for x, we'd get 0 here, win. If we substitute 2 for x here, we have 0, win. Okay, so we can easily check our answers. So now we know our solution set, right? Our solution set is x being equal to either negative 1/5 or positive 2. Okay, and again, I go back to our notes on vocabulary, right? Remember what solving is. We're going to undo operations. We're going to isolate variables, because the question is, what are the possible values to make a true statement? The possible values to make a true statement here, if x is negative 1/5 or if x is 2, win. Okay, we'll do something with that in the next lesson, but that's how we use the zero product property. Okay, that's how that works. So questions on this, you got to hit pause, rewind, watch it again, and go back to especially the note on the zero product property. Okay? Okay. Number 2, take a look at this garbage. So we have spent so much time in this unit on factoring. And the name of the unit has been polynomial equations the entire time, but we've spent so much time on factoring. Why? Well, now, here's why. Because in order to solve this, it would be easier to break this down into its factors. Let's see. Okay, so to use the zero product property, we're going to have to factor first. So to use the zero product property, we must factor first. That's a huge note. Oh my goodness. Because we can't use products without showing products. That's what factoring does. So you got to remember the very first note of the very first lesson in the entire unit. The whole thing is like coming around full circle. It's beautiful. So to use the zero product property, we must factor first. And that way we can see the independent factors that equal 0 if we multiply them, and then use our logical exercise for the zero product property. So let's see what that looks like. We're going to factor this first polynomial. Hopefully you see we have a greatest common factor of x. Okay, so hopefully you see that we have a greatest common factor of x. We'll be left with x squared plus 11x plus 24, and all of that is equaling 0. Okay, so we're factoring. Okay, so the whole thing is equal to 0. We're going to factor. Now we look at here, we can totally factor that. The two numbers that multiply to 24 yet add to 11. Two numbers that multiply to 24 yet add to 11 are 8 and 3. So it doesn't matter how you're factoring this. You can use mental math. You can use x factor. It doesn't matter. We have now our completely factored form. So remember the whole goal. To use the zero product property, we got to factor first. Bam, we factored. And now that we have factored, remember the zero product property kicking in. Okay, so the zero product property, if multiple things are being multiplied and the result is 0, that means each thing could equal 0. Okay, so remember what the zero product property is saying. If we have things being multiplied and the result is 0, then either the first thing is 0, or the second thing is 0, or however many things are being multiplied is 0. Okay? So look at what's happening here. We have 3 things being multiplied. Right? So we have three things being multiplied, and their product is 0. So therefore, we have 3 possibilities. So either our x is 0, or x plus 8 is 0, or x plus 3 is 0. So we have these possibilities based off of the logic of the zero product property. So we have these 3 possibilities set up, and we solve each one. And so in this case, we have x equaling 0. That's easy enough. In this case, x is equal to negative 8. And in this case, x is equal to negative 3. And that is our solution set. Okay, so we have 3 possibilities. So if I plug in 0 for any of these, it's going to be a true statement. If I plug in negative 8 for any of these, it'll be a true statement. And if I plug in negative 3 for any of these, it'll be a true statement. So that's what that means. And to check your answers, just plug it back into the factored form, and it's totally going to work. So what is the solution set? X could be 0, x could be -8, x could be -3, and we just solved some crazy equation by using the zero product property. And that's why we have spent the entire time factoring. So we took this crazy equation, set it equal to 0, factor it, blam, and we're good to go. And that's how we solve these equations. Everything else is just crazy talk, right? So take a look at number 3. Speaking of crazy talk, that is a crazy looking equation, but it's totally doable. And how is it doable? Well, by using a couple of skills. All right. So with number 3, we have a crazy looking equation. I'm gonna give you a couple of notes to take, and you should be good to go. So we got this crazy looking equation. Now, there's going to be a couple notes. First of all, you see fractions, right? Yeah. And do we like fractions? Well, I do because I'm a nerd. But do you? Maybe not. So how did we deal with fractions? You got to think way back to the beginning of the year. How do we deal with fractions? We can clear them. And how do we clear fractions? By multiplying everything by the denominators. So we're going to multiply everything by the denominators. Now, let me give you a hint here, okay? But I have 3 different denominators, Mr. Katz. I totally agree. So if you want to multiply everything by 2 first, then by 15, then by 30, you can do that. I wouldn't. Okay, so multiply by denominators. I would multiply by the biggest denominator first. Okay, so I would say the biggest denominator first, and you will see why. It's basically the least common denominator. So you want to multiply by the least common denominator. Biggest denominator first. And if you have a hard time identifying the least common denominator, it's all good if you'll do this. So clearly our biggest denominator is 30, right? So we're going to multiply everything by 30. And if you remember how that looked, we had to multiply the numerators, right? So always multiply your numerators. So multiply the first one by 30, multiply the second one by 30, multiply the third one by 30. Okay, so we have to remember how all of that worked. And now we see some interesting things occurring. And if you are still struggling with this, hit pause here, make sure you understand it, and then get back to work. Okay, so make sure you understood what just went on. Okay, so hit pause here if you don't get it, and then understand it, and then get going. All right, so now for the first term, we've got 30 divided by 30 cancels, leaves us with y squared. And if you don't understand what just happened there, hit pause, think it over, and then you'll see what happened. So we have y squared equaling, now 30 divided by 15 here. You know what 30 divided by 15 is? 2. So it's going to equal 2y. And again, another tricky part. Hit pause if you don't understand what just happened. And then the last one, 30 divided by 2 is 15. All right, so our fractions are now gone. Okay, so that's the first big thing, clear fractions. All right, and if you don't understand what happened, hit pause, make sure you understand it. Now the second big thing is we have y to the second power, which means we have to use the zero product property. Okay, so we must use the zero product property, but this doesn't equal 0. So what can we do? So we have to use the zero product property, but it doesn't equal 0. What can we do? We do what's called set it equal to 0. Set it equal to 0. And that just means undo stuff until you get a 0 on one side. Okay, so that just means undo stuff until you have a 0 on one side. All right, undo stuff until you get a 0. So that's the zero product property. Undo stuff until you get a 0. So if I look at this, I'm going to actually undo 2 things. Personally, I like to keep my my lead exponent or my lead coefficient positive. That's just a personal thing. So if I have y squared minus 2y plus 15, I'm going to undo stuff until I get a 0. Okay, so I'm going to do it all in one step. I'm going to undo this and this. I'm going to undo them both in one step. Check it out. I have to subtract 2y from both sides, right? And then I would subtract 15 from both sides. I would end up with this. See, I undid stuff until I got a 0. Now, if you don't understand what just happened, again, hit pause, do it the hard way, show your work and all that stuff, I guarantee you we're going to agree to the same thing. Okay, so here's another pausing point. So now we have our equation set equal to 0. And now that it's set equal to 0, the zero product property is in full effect, we can now factor this bad boy. Okay, so now we can factor it. All right, we have y squared minus 2y minus 15, totally factorable. Okay, so you use x factor, factor by grouping, mental math. I'm going to use mental math. Okay, so two factors that multiply negative 15 but add a negative 2, negative 5, positive 3. And all of that is equal to 0. Okay, and if that's equal to 0, well, I can now use zero product property. All right, so I have y minus 5 equals 0, or y plus 3 equals 0. Okay, so now I'm using the zero product property. So you got to remember, that's the new note, zero product property. If multiple things are being multiplied, their product is 0, then either term is 0. Right, they're being multiplied, so either one is 0. So notice how all of this is building on nodes. So y could equal 5 or y could equal negative 3. That means the very beginning, like this crazy equation with all the fractions and stuff, if y was 5, it would work, and if y was negative 3, it would work. Isn't that weird? So y could equal 5, y could equal negative 3. We have now solved that equation. All right? There's a reason why in the next lesson you'll see. So even crazy looking stuff, like number 3, even crazy looking stuff like number 3, we can totally do that. But now we get into even crazier looking stuff. Look at number 4. There's a lot of interesting things that are going on here. Okay, so with number 4, this is going to be nuts. So with number 4, we have to do a couple of interesting things. Now clearly, we have to use the zero product property because we see an x squared, which is in fact an x to the third power, but we'll get to that in a second. But we need to use the zero product property. We have to set this equal to 0. Okay, so the first thing we have to do is realize we got to set this equal to 0. This is not equal to 0. We must set equal to 0. Now, before I actually do that, I'm going to do something else first. What I'd like to do first is simplify this left-hand side. Can I clean this up? Can I clean this all up before I subtract my 26x? Okay, so before I end up subtracting my 26x to set it equal to 0, can I clean up all of this garbage? And that's the key question. So if you don't understand what I just wrote, pause here, refer back to the notes, go back over numbers 1, 2, and 3, and then make sure you understand what we did. All right? So if what I just said here doesn't make any sense, go back, pause to 1, 2, and 3, and the note. Otherwise, let's clean this up. So the first thing I'm going to do is actually distribute. I'm going to call this 5x to the third power plus 3x squared. Okay, I'm going to distribute this, 5x to the third power, 3x squared, and that's going to equal 26x. Now, why would I do that? You'll see, it's a neat trick. So why would I do that? I am going to now set it equal to 0. So now is when I'm going to set this thing equal to 0. Now I'm going to subtract my 26x. So I end up with 5x to the third power plus 3x squared minus 26x, and that's going to equal 0. Okay, so I have everything done for a specific reason. And now that it's set equal to 0, right? Now that it's set equal to 0. By the way, if you don't understand where this came from, hit pause, chew it, right? Make sure you understand everything that happened, and then we'll continue. So once I have this set up, I can now factor. I have it set equal to 0, factor it. And as you can see, there is a greatest common factor of x. So I have to factor out an x first. And then I'm left with this. Okay? So all I have to do now is factor what's left inside the parentheses. And it doesn't matter which method you use to factor that. Personally, I'm going to use the x factor model. Like I've said before, when a is not equal to 1, I use the x factor model. And this one's going to be kind of simple because I have 5x here and x here. Now, what are the factors that multiply to negative 26? There's really only two choices. I got 2 and 13 or 26 and 1. Okay, so you can start messing around with stuff and you can figure out, well, how am I going to write that? But since I know I got a 5x over here, I'm going to be multiplying by whatever comes across here. And eventually, I'm going to add to positive 3. What I'm going to do is put my 2 here and my 13 here, okay? Because I know that's what's going to work eventually. Okay, so you'll see in a second. So let's test this out. I got 5x times 2 going down one way is 10x. X times 13 is 13x. How can I manipulate that where I'm left with a plus 3x? That means my 13 has to be positive. My 10 has to be negative. Okay, so if that doesn't jive well, hit pause here. Go back to the lesson on factoring trinomials. All right, but again, I'm trying to sell you on the x factor model. This is why I use it. So anyway, if my 10x is going to be negative, that means where I came up with my 10x is going to have to be negative. If my 13x is positive, where I came up with that is going to be positive. So clearly I can see I've got 5x plus 13 here, and then x minus 2 here. So I've now factored out. And again, if any of this, what I just did, is confusing, hit pause to make sure you understand it. If not, go back to the video on factoring trinomials. So now I'm completely factored this expression. And once I've completely factored the expression, zero product property. Excuse me. So now I'm ready for the zero product property. So it's funny how all that time we spent factoring is used to solve equations. So if I'm using zero product property, it means x could be 0, 5x plus 13 could be 0, or x minus 2 could be 0. So all of that is possible. So x could be 0, x could be negative 13 over 5, or x could be 2. And all of these are our solutions for the original equation. Okay, so we have now used the zero product property to solve. Remember, all that time we spent on factoring was for a purpose, right? It was factoring with a purpose. And so when we look at this original equation, we've got 3 possible solutions: 0, negative 13/5, or x equals 2. And now on to number 5. And hopefully you see number 5 is very similar to number 4. Okay, hopefully you see that number 5 is very similar to number 4. We've got a crazy looking thing. We have to simplify some stuff and then use the zero product property. Okay, so even though it looks crazy, let's see what we can do. All right, so let's clean up our stuff. First things first, we're going to clean up this side. So we have 2a squared plus 12a, and that's going to be equal to 2a squared plus 12a minus 8. Right? So we're going to clean up our stuff, and we're going to see if we can set this thing equal to 0. And if we're going to set it equal to 0, we can move everything to either one side or the other. Okay, so we're going to undo to set equal to 0. Undo to set equal to 0. So I can subtract this 2a squared, and I can subtract this 12a from both sides. Right? And look what's going to happen. I have 0 on one side equaling, so if I subtract 2a squared here and minus 12a here, look what happens. This cancels, and this cancels, leaving us with negative 8. What? What in the world? What just happened? Not again. Mr. Katz, I thought we were done with that. We're never done with that. This actually means something else later, but we're never done with this. So if 0 equals to 8, what just happened? Right? What just happened? Do you remember what that means? That means there's no value for the variable. In this case, the variable is a. There's no value for a that would make a true statement. Right? So what does that mean? No solutions. Right? So there's no value for a that would make a true statement. That means there are no solutions. Okay, so it doesn't matter what we plug in for our variable, it'll never work out because, again, this goes back to vocabulary. What is the solution? The possible values to make a true statement. All right? And there are no possible values to make this a true statement. So all that craziness in number 5, and there are no solutions. So we have to be aware that that could happen every now and then, so just be cautious. All of that for finally the real world problem. Okay, so we're going to set up a real world problem. A rocket launch is modeled by the equation h is equal to negative 16t squared plus 144t, where h is the height in feet and t is the time in seconds. So I'm going to ask you two questions. Question number one, how long will it take for the rocket to reach 128 feet after liftoff? And then the second question, how long will it take for the rocket to land after its launch? Okay. So in number one, we've got something, or in number 6a, we've got something interesting. Okay, so first of all, it's a rocket. And what we want to do is draw a stinking picture. DASP. What's happening? A rocket lifts off, right? And what's going to happen? The rocket goes up and then comes back down, right? That's what's happening. You have to understand that's what's going on. And it is modeled by the equation h is equal to negative 16t squared plus 144t. All right, so that's the model. Now, in question A, it's asking how long will it take? Okay, so in question A, how long will it take? Do you know what that means? That means we're looking for t, right? So in question A, it reads, how long will it take? We're looking for t. All right, so if the question is asking that, that means we have to find what t is. All right, so how long will it take for the rocket to reach 128 feet? All right, so now we know what the h, right? This gives us h. So 128 feet is our h. That's what this does. It gives us our h. Okay, so it tells us 128 feet is h. And now what we can do is substitute and solve, right? The hard part is done. Once you see that, the hard part is over. So it's telling us 128 is h. That's equal to negative 16t squared plus 144t. We can now solve for t. Okay? So now what we're going to do is solve for t. And we have to use the zero product property. So what are we going to do? Set it equal to 0. Okay? So we're going to set equal to 0 and then see what happens. And by setting it equal to 0, we can either add all this stuff to one side or subtract all of it from one side. I'm going to add it all. So I'm going to add 16t squared. I'm going to subtract 144t. And then my 128 is already there. And that's going to equal 0. And if you don't understand what just happened here, hit pause. Okay? If you don't understand what happened, hit pause and make sure you follow the steps that got me to this equation. And now I'm going to factor the equation. Right? So there's a GCF here. It's 16. And if I factor out of 16, I'm going to be left with t squared, and then whatever 144 divided by 16 is, right? So I'm factoring it out. So I do 144 divided by 16. That gives me 9. So I have minus 9t, and then 128 divided by 16. Right? So whatever that is, in this case 8, is equal to 0. Right? So by factoring out the 16, this is what I'm left with. And now I can factor that trinomial without a doubt. So if 16 times, this is going to be t minus 8, t minus 1, equaling 0. Which means then, zero product property, that t is equal to 8 or t is equal to 1. All right, so now, here's where we have to go back to reading and thinking. Okay, so now we're going to read and think. Remember what the question was. How long will it take to get to 128 feet? Okay, so how long will it take to reach 128 feet after liftoff? So notice what's happening. It's reaching that distance twice, right? So that means it's reaching that distance twice. It's reaching at 1 second, and it's reaching at 8 seconds. That's what this means. So we're reading and thinking. So it's reaching that height at 1 second, and it's reaching that height at 8 seconds. Since the question is asking for after liftoff, well then clearly, remember the DASP, it's reaching 128 feet after 1 second after liftoff. So the answer is 1 second. How long will it take to reach 128 feet? 1 second. And then that's how we can solve that, by doing some reading and thinking after DASP. But remember, I asked for a different question as well. How long will it take for the rocket to land after launch? Right? So for the question B, how long will it take for the rocket to land after launch? Well, in problem B, guess what the height is going to have to be? Right? This is the neat question. So for problem B, the main question is, well, what is h going to be? Right? If I'm asking for how long will it take for the rocket to land, guess what h is? Hopefully you guessed by now. It's 0. So for our model, right, for the model that we had, h is equal to negative 16t squared plus 144t. In question B, h is now set up to be 0. So the question is quite straightforward. How long will it take to land? Okay, so remember the DASP. It's a rocket shooting up and then landing again. Okay, so how long will it take to land? We're pretty much done. Solve for t, right? We can use the zero product property right here. Factor out a negative 16t, right? Factor out a negative 16t. We'll be left with t minus 9. When we factor out a negative 16t, we'll be left with t minus 9. If you don't get what just happened, hit pause. Make sure you understand factoring. And now we can see here, well, that negative 16t could be equal to 0, or t could be equal to 9, right? So t could be 0, or t could be 9. That means it's reaching 0 twice, okay? The first time it was at 0 was right at the beginning, right? The first time it was on land was right at the beginning. And it took 9 seconds to hit land again. So it took 9 seconds to hit land again. Bloop. So here is at 0 seconds. Here is at 9 seconds. And we have now answered the question. Remember the question was, how long will it take after the rocket launched to land? And it's going to take 9 seconds. So there's our answer. It takes 9 seconds. And that's how we can use all of this stuff, right? Factoring and whatnot to solve equations. So everything we've done in this unit builds up to all of this skill. And all of it revolves around the zero product property. Thank you very much.